Hey guys, welcome back everybody. Hope you all are doing great. Guys, today in this video we are going to discuss BGP configuration in real-time network. We will discuss a step-by-step BGP implementation in this scenario. And guys, this is real-time scenario. You can see here I have two types of network. This is service provider network and these two are sides of customer, right? Side 1 of customer A, side 2 of customer A. Same customer have two sides. In any another video we will also discuss what if we have multiple customer, right? So guys, in this case you will always configure BGP in the production network. Okay, so like between P to C or within the service provider P to P we will configure BGP. Apart from the configuration and basic rules of BGP, we are also going to discuss one commonly asked scenario-based network engineer interview question here. So if you are a network engineer or if you are planning to become a network engineer, make sure you will watch this video till the end. And guys, at the end, don't forget to share your feedback. Okay, so let's begin. See, first of all, let me tell you about this topology. Guys, see, in the service provider network, this is service provider network, this section. This is service provider network. Okay, in the service provider network, generally we have two types of router. First one is PE router. PE means provider edge router, who is connecting customer network and provider network, means service provider network to the customer network. And the second type of router in the service provider network is P router, provider router, right? You know the difference between P router and C router. If I will talk about the physical hardware, so guys, all the P routers, like for an example, router 4, router 2 and router 5, these are P router. So all the P routers are simple configuration router. These routers cannot handle lakhs of prefixes in their routing table. Now, if I will talk about PE router, provider edge router, so these routers are high configuration router. These routers can handle lakhs of prefixes, right? So that's why whatever PE router is connecting customer are responsible to handle customer prefix. For an example, see here inside one of customer there is one LAN network 10.1.1.0/24. So customer edge is going to advertise it to P router. Now PE router cannot advertise it to P router because what I told you, like this we can have lots of customer which is connected to this service provider network, right? If for an example lakhs of customers are there, lakhs of customer or 1000 customers are connected to this service provider network and all the customer are advertising for an example only 10 numbers of subnets, so you can calculate the number of subnet prefixes in the routing table of P router, right? And if P router is going to advertise that to P router, then P router will start hanging, right? CPU utilization will reach to 100%, right? Then performance will automatically reduce. So we will never advertise customer networks in the routing table of P router, all the P router. So that's why we will always configure BGP between PE to PE. PE to PE. Now again, between PE to PE, we cannot configure BGP neighborship through physical IP address, right? That's why here I have created loopback. For an example, between R1 and R3, I want to configure BGP neighborship. What if I will use this interface and this interface IP address for BGP neighborship, guys? If I am going to tell to router number 1, your neighbor is this interface IP 43.1.1.3. So what will happen? When router 4 or this link will goes down, your BGP neighborship will goes down, right? Customer sites will be not able to reach each other. But we have alternate path as well between P to P, between router 1 to router 3, between customer A side 1 and customer A side 2. We have multiple paths in the service provider network. 3 paths are there, right? So router 1 can reach 3.3.3 via router 2 also, via router number 5 also. So that's why we will never configure BGP neighborship with the help of physical IP address. That's why here I have created what? Loopback 1.1.1 and 3.3.3. Now to configure BGP neighborship between 1.1.1 and 3.3.3, first of all we need reachability. So for the reachability I am running what? OSPF. OSPF is only responsible to make reachability between PE to PE, right? Between, for an example, this is PE1, this is PE2. So how PE1 and PE2 are reachable with each other, that is responsibility of OSPF. After that, we will form BGP neighborship between 1.1.1 and 3.3.3. Which type of BGP neighborship? Here you can see 1.1.1 and 3.3.3. I have BGP session. Which BGP session? iBGP, internal BGP session, because I am running BGP AS number 100 in the service provider network. Hope it is clear. And guys, between P to C and customer edge router is called C router. So between P to C, we are going to configure eBGP. Here we have eBGP session. Why we have eBGP session? Because service provider is using AS number 100. Customer can use any AS number over here, right? So this time customer is also using same AS number 100 and 100 only, right? But here I am going to make it 200, or here I am going to make it, let's say, 500, right? I think in the configuration my AS number is 500 in the service provider network. Okay, so let me check here and let me correct it. BGP AS number on router number 1. Yeah, 500 is there. So here also I am going to correct it. I'm going to make it 500. 500. Okay. So now you can see between P to P, I have iBGP neighborship, and between, now here my AS number is 500. Now between C to P, I have eBGP neighborship. So question is what? Question is, guys, after forming BGP neighborship between P to C and P to PE, and again P to C, eBGP, can these two LAN communicate with each other? I have advertised this subnet into the BGP over here, and I have advertised this subnet into BGP over here. Now, can these two sites communicate with each other? Now, you can pause the video and you can check. If you are thinking, yes, it can communicate, ping will work, then again you are wrong. That means you don't know the basic rules of BGP. We will discuss about this rule. First of all, let me implement the BGP over here. Okay, and guys, I'm not going to configure the scenario from the scratch, right? Definitely will configure from the scratch, but I have configuration in Notepad for the IP addresses and OSPF. Here you can see, first of all, we are going to configure service provider network. And in the service provider network, I have how many routers? 5 routers are there. Okay, so I have IP configuration and OSPF configuration for all these 5 routers. For an example, on router number 1, you can see, and I will put this commands in the description, right? I will put a link to download this file, from where you can get the configuration and you can practice by yourself as well. Okay, so on router number 1, you can see my IP on F0/0 is 12.1.1.1. Here also you can see the subnet between router 1 and router 2, right? Then I have configured OSPF network type point to point over here. I have enabled OSPF area 0, and after that I have also enabled MPLS, because what I told you, provider routers are not going to install customer networks in the routing table. Then how provider routers are going to forward the traffic? On the basis of label. This is when MPLS comes in picture, and when we will have multiple customers, then VRF comes in picture. Then VRF will comes in picture, and when VRF will comes in picture, then you have to learn MPBGP. So in this series we will discuss those parts also. Okay, so I have enabled the MPLS. Then on another interface F1/0, you can see the IP configuration, OSPF configuration, and MPLS configuration. On all these 3 links, I have configured the IP address, I have enabled the MPLS, and I have enabled the OSPF. Also on loopback interface, I have enabled the OSPF. Okay, so on loopback 1 also you can see only OSPF is enabled. After that, this is the interface F3/0, which is connecting CE router, customer router. There I have only configured the IP address. I have not enabled OSPF. OSPF is not running there. So let me copy the command of router 1 and let me paste it on R1. R1, copy, and let me access it. R1 device. and let me paste it over here. By the way, IP is already configured, but again I am going to paste all the commands. You can see all the commands are accepted over here, but I have not enabled BGP till now. On router number 2 also, let me paste the command. Where is R2? Here it is. Copy. On R2 there are only two interfaces. So on both interfaces I have configured the OSPF and I have enabled the MPLS. That's it. Go to R2 and paste the command, and after that I don't need to configure anything on router number 2. So let's close the console. In the same way on R3 also, paste all the commands. I will put these all commands in description. You can check. Okay, copy and let me access R3 and let me paste it over here. Right, I need R3 console for the BGP configuration, so I'm not going to close it. On R4, this is again P router, provider edge router. Here we will only paste the configuration, and then after that we will not configure anything else. R4 till here. Done. Then close the console of R4 also, and finally R5. And on R5, let me paste the commands. Here is R5. Copy and paste it. Right, now let me close the console of R5 also, because we are not going to configure now anything else on provider routers. On provider routers we have only configured the IP, we have enabled the OSPF, and we have enabled the MPLS. That's it, right? And now I am going to check connectivity between 1.1.1 and 3.3.3, and I am hoping there should be reachability. Ping 3.3.3.3 source 1.1.1.1, and you can see guys there is reachability, both are able to communicate. So now we can configure BGP between 1.1.1 and 3.3.3, and for BGP again I have here commands. On router number 1, you can see I am going to enable BGP number 500, neighbor 3.3.3 remote AS 500, and neighbor 3.3.3 update source loopback 1. These are the commands. Let me copy it and let me paste it on R1. Config T and paste it over here. Done. This command will enable BGP. Let me copy the BGP configuration of R3. Here you can see neighbor 1.1.1, update source loopback 1, and remote AS. All the commands are there. Let me paste it on R3. Done. Now I am expecting BGP, iBGP neighborship between 1.1.1 and 3.3.3, and you can see the log message. Here I have BGP neighborship. Here I have BGP neighborship. So IP BGP summary. So you can see BGP 1.1.1 is neighbor, right? Receive prefix is 0 till now. Now I am going to configure eBGP between customer edge and provider edge. So I think configuration is there. Yeah, now here I have the customer router configuration, IP configuration on router 6. Let me put these all commands. See, this is only IP configuration on customer edge router. R6 access, say no, and R7 also. No, and let me configure R6 side 1 of customer 1 first. Okay, let me configure R7 first, then I will configure R6 again. R7, Done. And then finally R6, Control C, R6, copy and paste. Right, so we are done with the IP configuration on customer router. Now we need to configure eBGP neighborship. Let me take you to R6 and say router BGP, yes number here 100, and neighbor IP means R1 F3/0 IP address is 16.1.1.1, and I am saying remote AS what? Remote AS 500. Done. And I am going to advertise LAN subnet 10.1.1.0, 10.1.1.0 mask. Here I am going to say 255.255.255.0. Done. So IP BGP. You can see in the BGP table we are able to see the LAN subnet here, right? Now R1 R6 will advertise it to R1 to PE router. So let me take you to PE router R1. On R1, so IP BGP summary. There is only one neighbor 3.3.3. Let me configure the another neighbor also. Router BGP yes number 500 and neighbor 16.1.1.6 and remote AS here I am going to say 100. Now we will have eBGP neighborship between R1 and R6, right? Soon. So IP BGP summary, you can see the log message also, and here we have neighborship, and from this neighbor 16.6 router 6 it is receiving one prefix. Which prefix? So IP BGP, right? So now guys, here you can see R6 is advertising this 10 subnet to P router. Now P router will advertise it to other BGP neighbor. Who is other BGP neighbor? 3.3.3. So it will advertise 10 submit to R3. So on R3 also you can verify the BGP table. On R3 you can verify the BGP table. So IP BGP, right? 10.1.1.0/24 subnet is there, but this is not best, only valid. Why this is not best? Because of next hop. You can see, whenever BGP advertise prefixes to their iBGP neighbor, it does not modify next hop address, right? So that's why next hop is R6 IP address. So on router number 1 we need to run one extra command here. I have to tell to router number 1 to modify the next hop. Router BGP ES number 500 and neighbor 3.3.3.3 next hop self, right? Now it will advertise, it will modify the next hop IP address while advertising prefixes to 3.3.3. So IP BGP, here we can run clear IP BGP star soft in command once, and then we can check BGP table. So IP BGP, and now you can see this submit is valid as well as best, right? Next hop is R1 loopback IP address 1.1.1, which is reachable through OSPF. That's why this prefix is valid as well as best. Now it will advertise to R3 will advertise to R7 to other BGP neighbor. Before that I have to form BGP neighborship here. So IP BGP summary, you can see there is only one neighbor. Let me configure eBGP now between R3 and R7. So router BGP has number 500 and neighbor 37.1.1.7 and remote AS of this neighbor is going to be again 100, right? Then go to R7, and on R7 also let me configure neighborship. Let me enable BGP AS number 100 first and say neighbor 37.1.1.3 and remote AS of neighbor is 500, and let me advertise the LAN subnet network 20.1.1.0 mask 255.255.255.0, right? So now here you can see so IP BGP. So IP BGP. So guys, here in the BGP table we are only able to see self advertised prefix 20 subnet. Sorry, it was not visible on the screen. Sorry. Now you can see on R7 we have only 20.1.1.0/24 subnet, right? 10 subnet is not there. Even we have modified the next hop on router number 3. We have 10 subnet in the BGP table on R3. So IP BGP. You can see both the subnets are there in the BGP table of R3, 10 and 20. For 10, next hop is 1.1.1.1. Now R1 is modifying the next hop, right? And R3 will advertise this 20 submit to router number 1. On router number 1 also you can check the BGP table. So IP, BGP, yes, here 20 submit is there, but next hop is, guys, R7 IP address, right? So let me tell to R3 to modify the next hop IP address over here while advertising prefix to 1.1.1. R3 config T and router BGPS number 100, sorry, 500, and neighbor 1.1.1.1 next hop self. You can only run this command next hop self on border router. Always keep in mind this. Okay. Now on R3, so IP BGP we have similar output, but on R1 now both the prefixes will be valid as well as best. So R3, and let me check BGP table again. Let me clear the BGP table once. Opt in and then so IP BGP, and now you can see, guys, both the subnets are valid as well as best, because next hop for 20 is 3.3.3. Next hop for 10 submit is R6 16.6, which is already reachable. Okay, so now both the P routers have routes, customer route, right? 10 also, 20 also. But will I have other side prefix on router number 6 inside 1, or will I have side 1 prefix inside 2? Answer of this question is again no, because of eBGP rule, right? eBGP rule. Let me show you first. Okay, here so IP route BGP. In the BGP routing table you can see both the subnets are there on P router, both P routers, so IP route BGP, right? Both subnets are there on P router. But if you will check the C router, customer edge router, right, on R6 for an example, so IP route BGP, you can see it is not receiving any route through BGP. So IP BGP, there is only 10 subnet self-advertised prefix, right? 20 is not there. Now question is why? This is the interview question. Why these two sites cannot communicate with each other even after enabling BGP? There was one issue first, which is the next hop issue, right? Which we have already resolved by running command next hop self. What is the another issue, guys? And we had discussed next hop self concept in previous video also. Now what is the next issue? Next issue is loop avoidance of eBGP. What will happen when R6 will advertise this submit to R5? Will it include their AS number? So you know, whenever BGP advertise prefixes to their eBGP neighbor, it always include AS path, right? So AS number in the update message is going to be, in the update message there will be NLRI information first of all, 10.1.1.0/24, and AS path is going to be what? 100. Correct? When, guys, R1 will advertise it to R3, will it include AS path? No. When BGP advertise to their iBGP neighbor, it never include AS path. It never add AS path. So AS path is going to be same 100. Right? When router 3 will advertise it to C router, will it add AS path? Yes. Right? So AS path is going to be 100. 100 is already coming, and it is going to add 500 also. 500. Right? And when this C router will receive, it will find their own AS number in the update message. Right? And you know, the loop avoidance mechanism of eBGP is do not accept the update message where you find your own AS number. Right? So same problem is here. Same issue we have here in this scenario. Let me show you. On router number 3 or on router number 1, let's say on router 3, so IP BGP neighbor 37.1.1.7, and let me say advertise prefix, advertise route. So you can see router 3 is advertising 10.1.1.0, 10.1.1.0. Router 3 is advertising to router 7, but router 7 is not accepting it because of loop avoidance. On router number 7, so IP BGP, I don't have route. So here we need to add one extra command to allow AS in, right? So router BGP AS number 100, and here I am going to say neighbor 37.1.1.3 and allow AS in. After running this command, so IP BGP, So IP BGP, now you can see both the subnets are there in the BGP table. In the same way on R1, which is my another P router, here also I have to run this command, not on R1, sorry, on C router R7, on R6, sorry, not 7, 6. So IP BGP, because here we have only 10 subnet, let me allow yes, router BGP yes number 100 and neighbor 16.1.1.1 and allow yes in, and after running this command, so IP BGP, you can see prefixes are there in BGP table, both the prefix. Now you can check the routing table also, so IP route BGP, right? So on router number 6, on router number 6 I have 20 subnet, and on router number 7 I will have 10 subnet. So IP route BGP, so IP route BGP, right? So this is how we are implementing BGP in this scenario between C to P and between P to PE. Okay, hope it is clear. Now you can check the connectivity, guys, reachability between side 1 and side 2, ping 20.1.1 and source 10.1.1. You can see ping is working. Even if you will check the routing table of any P router, let's say R4 or R2, you will not find 10 and 20 subnet. So IP route, you can see 10 or 20 subnets are not there in the routing table. So how these P router provider routers are forwarding to the traffic on the basis of label? That is the concept of MPLS. If you don't do the MPLS, it can be magic for you. But guys, later you will also learn the MPLS in this series. I will tell you the basic about MPLS here also. By the way, one separate playlist is there for MPLS where you can master the MPLS technology. Okay, so this was the basic BGP implementation in these kinds of scenario. In next video we will discuss another scenario, some advanced scenario from this concept. Okay, so question was, can these two sides communicate with each other after implementing BGP? So no, we have to run some extra commands here. Okay, that's all for today. If you have learned something from this video, guys, please hit on like button. If you have any question, query, concern, please let me know in the comment section. And if this video is helpful for you, please type helpful in the comment section. Please share your feedback. It will motivate me to make more videos like this. Thank you so much for watching. That's all for today. We will meet soon in the next video. Till then, stay safe. Bye bye, guys.